want to look at other questions that has to do with number bases, how we can convert a figure in a particular base that is unknown, and then to another figure, we equate it with another figure in another base. Let's look at some questions to portray this. We have a question: if 25 base x equals 32 base 5, find x. What we do in questions like this is we first of all convert to base 10. We convert to base 10. To base 10 first. So we have 25x 0 1 on top. That will be 2 times x raised to the power 1 plus 5 times x raised to the power 0. That will give us 2x plus 5. Then we convert this also to base 10. 3 times 5 raised to the power 1 plus 2 times 5 raised to the power 0. And that gives us 15 plus 2, that's 17. So what we come to do is 25 base x is the same thing as 2x plus 5. So we say 2x plus 5 equals 32 base 5 is the same thing as saying 17 base 10. So these are based in base 10. So 2x will be 17 minus 5. 2x is equal to 12. X becomes 6. So it means that 25 was in base. 25 base 6 is the same thing as 32 base 5. We have questions like this. We convert everything, we equalize them, we bring them down to base 10, all of them, then we can solve the question. What's the value of 3? What is the value of 3 in 312 if the number is... What's the value of 3 in 312 if the number is in base 10? If it's in base 10, what do we do? That will be 312. If it's in base 10, that means 3 is 300. This is 312. So it's 300. Now, if the number is in base, if this number is in base 8, what do? We say 312 base 8, 012. That will be 3 times 8 over 2. This 3 is 3 times 8 over 2. And that will be, is 3 times 8 raised to the power 2. That's 3 times 64. And that's 192. So 3 in 312 in base 8 is 192. We will not need these other ones. Now, in base 5, if it's in base 5, that will be 312 base 5. So we have 3 times 5 all over 2. And 3 times 5 raised to the power 2 plus 1 times 5 raised to the power 1 plus 0 plus 2 times 5 raised to the power 0. We are concerned about the 3. So this will be 3 times 25. And that will be 75. So 3 in 312 in base 5 will give us 75. In ascending order. That is, from smallest to biggest. We have 41 base 5, 1011 base 2, 111 base 2, 26 base 8, and 110 base 4. How do we arrange all this in ascending order? The best way to do this is to convert everything to base 10. So 41 base 5 will be 01, that's 4 times 5 over 1 plus 1 times times 5 raised to the power 0, and that will give us 4 times 5, 20. That's 20 plus 1. That will be 21. Then we come 1, 0, 1, 1, 1, 2. Be 1 times 2 raised to the power 4 plus 1 times 2 raised to the power 2 plus 1 times 2 raised to the power 1 plus 1 times 2 raised to the power 0. That's 2 raised to the power 4. That's 16. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 plus 4 plus 2 plus 1. That will be 20, 23. Then 26 raised to the power 8. That will be 2 times 8 raised to the power 1 plus 6 times 8 raised to the power 0. And that will give us 16 plus 6. That will give us 22. Then the last one, 1, 1, 0 raised to base 4. That will be 1 times 4 raised to the power 2 plus 1 times 4 raised to the power 1. And that will be 16 plus 1. That gives us 17. Because 1 times 4 raised to the power 2 is 16. This is 1. This 1 times 4 raised to the power 1, that's 4. Is 20. So if we are to arrange this in ascending order, the smallest is 20. So our answer will be 4, 1 raised to base 5, 1, 1, 1, 0, 1, 1, 1 base 2, then 26 base 8, 1, 1, 0 base 4. If we are to arrange it from smallest to the biggest, 20 is this. So it will be 1, 1, 0 base 4. Then 21 is 41 base 5. Then 22, 26 base 8. And then the last one will be 1, 0, 1, 1, 1 base 2. This becomes our answer. Another question, what is the value in base 10 of the digit 1? What is the value in base 10 of the digit 1, this one, in each of the following? We have 1, 0, 0 base 2, 2, 1, 4 base 5, 1, 2, 0, 3 base 4. We are asked what is the value in base 10 of 1. This one, what is its value? 0, 1, 2. So what's the value of 1 base 1? This 1 in 100 base 2. What is the value of this one? That will be 1 times 2 raised to the power 2, and that is 4. So the value of this one is 4. What about this? Of this one, that will be 1 times 5 raised to the power 1. That's 5 times 1 is 5. So 5. 0, 1, 2, 3. So this will be 1 times 4 raised to the power 3. And that is 64. So, how did we do this? Everything is in different bases. Then, what is the value in base 10? So we convert them to base 10. So this will be 1 times 2 raised to the power 2. That's 4. This is 1. We will not start from this because we are looking for 1. That will be 1 times 5 raised to the power 1 times 5 raised to the power 1. That's 5. Then we have 1 times 4 raised to the power 3. 64. That becomes our answer. m base 4 equals n base 8. When we have a question like this, we are asked to look for find find the value of m and n. So what we'll do is we convert to base 10 all of them. What is here? So we have m base 4, 0, 1, 2. That will be m times 4 raised to power 2 plus m times 4 raised to power 1 plus m times 4 raised to power 0. And that will give us 16m plus 4m plus 4 raised to power 0 is 1 plus n. What does that give us? That's 21m. 4 times 4 is 16. 4 raised to power 1 is 4. So then we convert n also 0, 1. That's n times 8 raised to power 1 plus n times 8 raised to power 0. And that gives us what? 8n plus n. 0 raised to power 8 raised to power 0 is 1. 1 times n is n. So that gives us 9n. So what we have is 21m equals 9n. So m over n will be 9 over 21. M over n will be 9 over 21. So our m is equal to 9 and our n is equal to 21. We can simplify further by saying, we can say 3 here 3, 3 here 7. So we have m over n equals 3 over 7 over 7. So m equals 3, n equals 7. This becomes our answer. With this, we've come to the end of number basis. Thank you for your time. See you in the next class.